Hello everyone, welcome to PUC Physics Explained channel. In this session, I am going to explain the chapter 1 units and measurements. In that, I am going to take the first two parts, that is 1.1 introduction, 1.2 the international system of units. This is the first session of the first chapter. Already in the previous session, I have discussed the content of the PUC First Year Physics. After referring that, we can go one by one chapter, and in that, the part by part we'll discuss. And here, in this one, the along with the explanation, what the study material is required, that is also I have provided in the PPT, so that you can have the ready reference material for your preparation, so that it will become easier to you. And in this one, first chapter, the units and measurements. As we know that there are number of physical quantities in the world and around us, and those physical quantities are to be measured. How those physical quantities are to be measured? And that requires a number and a unit. To have that one, the what the number and unit it has, we have to know that the standard unit of the measurement. The standard unit of the measurement here I'm going to take in this one. The first about this units and measurements, why it is required, will take. And later, the international system of units, which is presently using for the measurement of all the physical quantities that I'm going to discuss. Kindly subscribe PUC Physics Explain channel. If you are already subscribed, kindly share and comment. First, I'll take the introduction. Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, that is, appropriately, it should be chosen, internationally accepted reference standard. Okay, measurement requires one reference standard, and that standard should be basic, basic and arbitrarily chosen. That is wisely we have to choose the suitable. It should be and internationally accepted. It should be internationally accepted. And that reference standard, what it is there, it is called as a unit for the measurement. The result of a measurement, if you measure anything, the result what we'll have of a physical quantity is expressed by a number. Okay, that result of measurement will have a number. That is a numerical value or a numerical measure accompanied by unit. It should be have the unit. The number and unit, why it is required to take, as we know here. If we go to the any shop, there if you ask the shopkeeper to give the some 5 grains, if the number only if you mention the 5 grains, what you should understand? The 5 number of grains you have to give, or 5 bags, or something else. And there the 5 you already have mentioned. If you unless and until if you mention its unit, it is not valid. And that's why the measurement requires number as well as unit. If you mention there 5 kg, then he can give the 5 kg of the grains. Otherwise, the 5 number of grains, only 5 numbers grains if you give, is that sufficient? Not. And that's why the measurement always have the number and the accompanied by its measuring unit. Further moving, although the number of physical quantities appears to be very large around us, there are a number of physical quantities are there. Can we have the one unit for each quantity? We cannot. Will be thousands of units we require. That's why we cannot have the units for all the physical quantities. But we need only limited number of units for expressing all the physical quantities. So that here for expressing all the physical quantities, only limited number of units we'll have. And these limited number of units are interrelated. with all other physical quantities so that we can express them in the having what the units, the standard units we already having. Okay, so that we can cover all the physical quantities what are there in the world since they are interrelated with one another. They have interrelated with one another. How this example will take that. We know that 1 kg of the grain, if the grain unit we have, then the same unit we can take for the other physical quantities also. The any commodity, the sugar also we have the same unit, the sand also we have the same unit, the kg, and the same unit we can have the for the other physical quantities like uh, stand, sand, or the other stone, like that any other physical quantity for them also the same unit we can use. Those are interrelated. The units for the fundamental or base quantities are called fundamental or base units. What I told, the few limited number of the units what we are going to choose which are interrelated with other physical quantities. Those are a fundamental or a base units. Those are a fundamental or base units. These units are used for the other physical quantities are also with the some relation. The units of all other physical quantities can be expressed as combinations of base units. The combinations we are going to take, even though the conversions we have, but also the combination of the unit also we can take the some other physical quantities. And such a the physical quantities and units what we are going to develop, those units, such a units obtained for the derived quantities, other quantities, those are called as a derived unit. The combination of the unit we are going to take. Later we'll discuss what are those combination of the units we are going to take, base units, how those are considered as a derived units. A complete set of these units, both base units and the derived units, known as system of units. Means here the both the system of units include both base units as well as the derived units. All together, the what the system we have, the group we have, that is called as a system of units. Here, the system of units, there are number of the system of units are there. Basically, the three system of units earlier used and presently one system of unit internationally accepted we are going to use. Then the what the units, the system we are going to discuss, that is a group of units which are including the base units as well as the derived units, and that system of units in that the one international system of units internationally accepted, earlier systems and present system we'll discuss in this part. In earlier times, scientists of different countries were using different system of units for measurement. Earlier, all the countries are not connected well, and that's why the different countries are using different units. And the few countries group also using those units only. And there are three such systems are there. Three such systems. One is CGS, the second FPS, that is called as a British system also, and third one is a MKS. There the elaboration I'll take further. MK system, wherein used extensively till recently. Till recently, that was used in practice. The base units for length, mass, and time in these systems were as follows. The base units, these are the length, mass, and the time are the base units for these we are going to take. And in these three systems, what are the base units are there for these physical quantities? In CGS system, they were centimeter, gram, and second respectively. In FPS system, they were foot, pound, and second respectively. In MKS system, meter, kilogram, and second respectively. And here we can see the three physical quantities, length, mass, and the time, and their units. The comparatively what we can take in the CGS, centimeter, in the FPS, it is a foot, and MKS, meter. And here the base physical quantities units what are there, those only given their name. Center gram second CGS, foot pound second FPS, and meter kilogram second MKS unit like this. The comparison we can take here the length is centimeter and in the FPS it is a foot and MKS it is a meter. And mass is gram in CGS, pound in FPS, and kilogram in MKS. And time will be remain same in all the systems second, second, second. Further moving the international system of unit that will take the system of units which is at present internationally accepted for measurement is the system internationally the unit. That is a French for international system of units. This international system of units, what it is there? It is the present system what we are going to use, and that is abbreviated as SI. The SI, S and I. The system international what we are going to take, that is a SI units. Abbreviated as SI. The SI with a standard scheme of symbols. It has the symbols for the physical quantities as well as the units. It has a standard symbols. That is units also the standard it is having and abbreviations. The abbreviations what are there? It is for the both the physical quantities as well as the units. Developed by the Bureau Internationale des Poids at Measures BIPM. This is the French name BIPM. At its meaning is the International Bureau of Weights and Measures. This is Bureau International des Poids at Measures BIPM. What is there? We can read like this: the International Bureau of Weights and Measures. And this BIPM head office there in the France, and that conducts the regularly meeting and any revisions, the variation in the standardness, all these things will be discussed and those are sets and implemented throughout the world. And in this one, about 64 countries are members of this one. And the members, those are developing the system and throughout the world it is accepted and using. And in it is developed in 1971 were recently revised by the General Conference on Weights and Measures. This General Conference usually conducts that meeting what I called in November 2018. That every frequently they are going to conduct these meetings, and a recent meeting was in the year 2018, and there the all the standards are discussed and set for the international acceptance. The scheme is now for international usage. The scheme is for the international usage for the scientific, technical, industrial, and commercial work of the measurement. For all these, we are going to use this SI uh, unit system, the system of international units. Because SI unit used decimal system. Decimal system means fraction. Also, we can use the fraction that is 0.01, 0.0235 like that. Decimal values also we can use here, and it has the conversions also. For example, if you take the length, it is expressed in the millimeter also, centimeter also, and meter also, and kilometer. Like that, the conversions it has, and decimal system also 1 centimeter 0.01 meter. Like that, the decimal system also it has. Within the system, a quite simple and convenient. And this because of this decimal system and conversion, it is a quite simple to use and convenient to use. The convenient is there because of that convenience. Presently, this SI system is using that is the international system of units for the measurement. Here, as I am mentioning, the fundamental units and the base units. And these fundamental units and the base units, they are the fundamental physical quantities. The seven fundamental physical quantities are taken for them. The unit symbol, their symbol, quantity, physical quantity symbol, SI unit, and their SI unit, and unit symbol are mentioned. Along with this one, there are two supplementary units, and the main units also we can call, those are also called as fundamental units or base units. And for them, we will take in detail. Length, its symbol is a L, its SI unit is meter, and unit symbol is a M. And length, already we know that length can be measured for the short length and longer length, all these things also. And here the short length like millimeter in the form of millimeter will take, and longer length it is a kilometer also we are going to take. Okay, that may be height of the human being in terms of the feet or a meter, and it may be a height of the building, it may be length or a distance between the two cities or distance between the earth and sun also. That is the length. Second one is the mass, it is a physical quantity. The amount of the quantity, that is the mass, and that symbol is m, that is measured in terms of the SI unit as a kilogram, and it is represented as a unit symbol kg. The mass of the any commodities or any the solid or liquid material, that we are going to measure in terms of the kilogram. Time, time is a unit symbol is t, and it is measured in second. And unit symbol is s. The time is the SI unit is in second. The other units conversion also we can have for this also. And electric current, that is a symbol is A, and its SI unit is ampere, and its symbol is A, unit symbol is A. How much electricity is flowing through a circuit? We have to measure it. Based on that only the energy will have. The electrical energy will have. And that's why the electric current, the measurement in terms of the ampere is required. The next is a thermodynamic temperature. The temperature by definition it is a the measurement of the hotness or a coldness. It is a sense of hotness or a coldness or a measurement of hotness or a coldness. The hot we are feeling, cold we are feeling, like that we can say. And how much cold and how much hot it is there, that is to be mentioned. And how we can mention that? That is in terms of the unit. Today is a 35 degrees Celsius or 35 plus 273. That is total in terms of the Kelvin. Okay, I like that will take. Okay, that 35 degrees Celsius or 40 degrees Celsius temperature what we can have, and the lower temperature what we can mention, even though that degree Celsius not SI unit, but that is have the relationship with this one. The temperature, which is unit symbol of the quantity is K, and its SI unit is Kelvin, and unit symbol is K. Okay, here the Kelvin, we have to know that one it is a SI unit measurement of the temperature, and other degree Celsius and degree Fahrenheit also will take the conversion, the relation this Kelvin is having, and by that it can be converted, and that I am going to discuss later. Luminous intensity, the luminous intensity or we can call as a light intensity, how much brightness is there, that is called as a intensity, light intensity. How much bright is a particular electric bulb? How much sunlight is having the brightness? Like that, what we can measure? That is the luminous intensity or light intensity. Its unit, the symbol of the physical quantity is CD, and its unit is candela, and the unit symbol is also CD. And fundamental units in that last one, amount of substance. The amount of any the substance at the atoms level or a molecular level, if you take any substance, and their quantity what we can measure, their amount what we can measure, that is in terms of the mole. That is in terms of the mole. That is a mole. It is a physical quantity symbol, and SI unit is also mole. MOL is a unit symbol of the this amount of substance. Usually, the physical quantities that is in terms of the molecular level, the molecules of the different the substances like the carbon, oxygen, carbon dioxide, nitrogen, like that. All these things we are going to measure in terms of the moles. And these are the seven physical quantities which are called as fundamental or base physical quantities, and their units what are there, those are the fundamental or base units. And even though there are seven are there, the five are commonly used in the daily life, and these two are the additional rarely used. Along with that, there are two supplementary units. Those supplementary units are concerned to the angle. The one is plane angle, which whose symbol is d theta, and SI unit is a radian, and unit symbol is RAD. And another one is a solid angle, and d ohm, its quantity physical quantity symbol, and SI unit is a steradian, and its unit symbol is SR. Okay, then these the angles what are there, how those are to be considered. Okay, that I will take, and definitions of all these units also I will discuss further. In SI, there are seven fundamental or base units as given in table 1.1 what I have discussed. Beside these the seven base units, there are two more units that are defined as plane angle d theta as the ratio of length of arc ds to the radius r, and b is solid angle d ohm as the ratio of the intercepted area dA of the spherical surface described about the apex O as the center to the square of its radius r, as shown in figure 1.1a and b respectively. That figure I will take in the next slide. The unit for plane angle is radian with a symbol RAD, and the unit for a solid angle is steradian with symbol SR. Both these are dimensionless. Okay, these are not having any dimension. That I'll discuss in the with the sketch. Dimensionless quantities. Here, this is the plane angle. Plane angle is angle subtended by the arc. The angle subtended by the arc. This arc is there. The angle subtended by that arc is a plane angle, and that can be given as arc length ds to the radius r. ds by r in terms of the radian. And this solid angle is angle subtended by the area dA. Angle subtended by the angle area dA with apex O, that we are going to take apex center O, and that is given by d ohm is equal to area subtended to the square of the radius, and that is in terms of the steradian. The other units definitions also will take further. Definition of SI units. All the SI fundamental units are there. Their definition will take. Meter, it is the length unit, and that unit is defined as the meter is the length of the path traveled by light in vacuum during a time interval of 1 by 299,792,458 of second, which is defined in the year 1983. It's a its definition. By the considering the some standard, it was defined. And next one is the kilogram, the unit of the mass. A kilogram is equal to the mass of the international prototype of the kilogram. One prototype is used as a standard there. A platinum iridium alloy cylinder. That is the prototype, and that is the standard reference for the development of this unit. Kept at International Bureau of Weights and Measures, which is kept at that BIPM, what we have discussed, and that Severus near Paris, France. It is, as we know that this BIPM, Bureau of Weights and Measures, which having the head office at the France. Okay, that there only it is kept, and it is defined in the year 1889. The second, the second is the unit of the time. The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperline levels of the ground state of the cesium-133 atom. By considering the cesium-133 atom, okay, so what the radiation is there, based on that, that time is set. And based on that only definition is taken for the second. That is defined in the year 1967. Ampere, ampere is a unit of electric current. The ampere is that constant current which, if maintained in two straight parallel conductors of infinite length, of negligible circular cross section, and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 into 10 raised to minus 7 Newton per meter length. The producing of this much of the force, the what the conditions they have mentioned here, that is the definition of this ampere, which was defined in the year 1948. Kelvin is a unit of temperature and SI. The Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature of triple point of water. Okay, the triple point of water, what it is there, is a point at which all the three phases of the water will coexist in equilibrium. That is the means here the solid ice, liquid water, and the water vapor. All three are coexist in equilibrium at one particular point. That point is called as a triple point, and it has the sum standard temperature and pressure, and that temperature what it is given here, that is taken, and that is taken as the base for the definition of the Kelvin, which is defined in the year of 1967. Candela, already we know that this is the unit for the luminous intensity or a light intensity. The candela is the luminous intensity in a given direction of a source that emits monochromatic radiation, the single frequency radiation, the monochromatic single frequency radiation of frequency, the frequency value what it is there, 540 into 10 raised to 12 hertz. Hertz is the unit of the frequency, and that has a radiant intensity in that direction of 1 by 683 watt per steradian. The watt is the unit of the energy and steradian unit of the solid angle, and which is defined in the year of 1979. Mole, the mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. The carbon is having the molecular weight of the 12. Okay, that the what we are going to take in terms of this, the mole we are going to define it. There is a 0.012 kilogram of that carbon what is there. It is the mole, that is a particular quantity. The same is used for the measurement of the other substances also. This is the standard one and used for the measurement of the other substances. And these the definitions already we have discussed for all the 7 fundamental units. And here the some units are retained for general use, though outside SI. The 7 fundamental units we have discussed, and the supplementary units, the two we have discussed already. Even though those are the units we are going to use, and apart from that, the some units are in general use, even though those are outside the SI, and those are minute, the MIN, it is a 60 second, and hour H is 60 minute, that is 3600 second. Day D symbol 24 hour, that is 86,400 second. Year Y, it is a 365.25 day, it is a 3.156 into 10 raised to 7 seconds. Degree, that is the exponential of the 0 we are going to take, as a 1 degree is equal to pi by 180 radian. The degree commonly we are going to use. The in terms of the radian, it is a pi by 180 we have to take it for the SI unit. Liter L, that is a 1 decimeter cube, that is a 10 raised to minus 3 meter cube. 1 liter is equal to 10 raised to minus 3 meter cube. Ton T 10 raised to 3 kg. Carat C 200 milligram. Usually the ornaments we are going to use this carat. Bar, the bar, it is a bar only. zero point 0.1 megapascal, that is equal to 10 raised to 5 pascal. This is a unit of the pressure. Curie Ci 3.7 into 10 raised to 10 per second. Roentgen R 2.58 into 10 raised to minus 4 C per kg. Quintal Q equal to 100 kg. 1 quintal is equal to 100 kg. Barn B is 100 mm square, that is equal to 10 raised to minus 28 meter square. Area A equal to 1 dA meter square, that is 10 raised to square 10 square meter square. Hectare HA, that equal to 1 HM square, that is equal to 10 raised to 4 meter square. Standard atmospheric pressure. In the atmospheric pressure around us, what the pressure is there? Okay, that is the standard atmospheric pressure. Usually it is measured at the sea surface, and the standard atmospheric pressure called, its symbol is a atom, 101.10132 pascal or 1.013 into 10 raised to 5 pascal. The pascal is a unit, SI unit of the pressure, and in terms of that we can express, or we can take 1.013 bar. Okay, these are the common units which are used for the general use, even though those are outside the SI unit. The important notes are about these units we are going to take here. The following conventions are adopted while writing a unit. Even if a unit is named after a person, the unit is not written in capital letters. That is, we write joules, not joules. The unit, the full unit which you write, that is joules we have to write. The second letter only, not joules, even though joule is the name of the scientist. For a unit named after a person, the symbol is a capital letter. Example, for joules, we write J. The symbol we should take in the capital letter. But unit, whole unit, if you write the second letter in initially we need to take. And the rest of them are in lowercase. If the name is not there, all other lowercase we need to take. The second is not a name of the scientist, that's why second letter only take. The any temperature, what it is there, that second letter K only would take. Like that, now all other will take in terms of the second letters. Only the, if the name of the person is there, that unit symbol we need to take capital, but whole unit in the second letter only. The symbol of units do not have the plural form, that is 70 meter, not 70 ms, or 10 Newton, not 10 ns. Only those are not having the plurals, only single unit we need to mention. Fourth, punctuation marks are not written. So punctuation marks, what are there? After the unit example, 1 liter equal to 1000 cc, 1000 cubic centimeter. And that is not, this cc cannot be written as c dot c. Okay, cc, the continuous we need to write the cubic centimeter. This is about the first two parts of the chapter 1, units and measurements, that is the introduction and the system of international units. The further parts or the sections I am going to discuss in the further sessions. Thanks for watching. If you like, share, subscribe and comment.